Good morning, everyone, and my name's Stephen Serjeant. I'm a professor of astronomy at the Open University, and I'm going to introduce the rationale for today's workshop. So, broadly, we are working in a project called ACME, which you'll be hearing about later. And part of what we want to achieve in this is to make all of our data findable, accessible, interoperable, and reusable. And this is a big open science objective of a thing called the European Open Science Cloud. And that data includes the sort of data that you collect and that you work with. And this is a very big continental-wide objective of science that we're taking part in. Now, our particular focus here is what people call the long tail of science. So, starting from the specialist community and going down into the much more numerous community of people who aren't necessarily paid to be doing science, but who are nevertheless making very real, in some cases very major, scientific contributions. And this we call citizen science. And there, the idea is that this is activity that is generating new scientific knowledge or understanding with a genuine science outcome. So sometimes people equate citizen science to public engagement or education or giving talks to the Cub Scouts or something like that, which is those are wonderful things to be doing, but the objective here is to do science. So an example of this is rummaging data from space telescopes like the Euclid Space Telescope. This is a beautiful recent image from Euclid. And rummaging the data to find rare things such as this. So this is a gravitational lens. This is where you have background galaxy lined up against just behind a foreground galaxy, and you see the background one through the warped space of the foreground one, and that distorts the background one into this arc shape, this curved arc. These are quite tricky things to pull out from data sets, so you need human beings to be doing this. So that's one very common use of citizen science. You absolutely cannot do this sort of science without the help of volunteers, but there is there's a growing area in multi-messenger astronomy of using this long tail of science to do tremendous things in data collection, because there is an overlap between the smallest professional facilities and the largest non-professional facilities. So there we need to coordinate and we need to work together and we need to agree on common standards for all sorts of things like calibration and so on. And so hopefully today you'll be hearing about some of the ways that this can happen with projects like the Grandma project, BH-TOM and Astro Colibri. And I believe we've got some representatives of these projects here. So that's the objective of today, is to try and have a meeting of minds between the professional specialist community and the people who aren't paid to do science. I mean, I try to avoid the term amateur astronomy, because it suggests a sort of pejorative overtone, but it's people who aren't paid to do this sort of science, and people who are just contributing their own resources, their own time, their own equipment to do some science and some things that cannot be done in any other way. So with that, I will stop sharing and I will thank everybody for coming and hand it over back to James for the next thing.
And yes, so the next thing on the agenda is Antoine Kouchner, who's the lead for ACME, the ACME project.
Hi everyone, I hope that you can hear me.
Yes, we
Hi.
can.
Good. I'm going to try to make the same success as Stephen and share my screen. And again, hello everyone. So I'm Antoine Kouchner, as it has been said. I'm the PI of this ACME project that I would like to present to you today. So ACME stands for Astrophysics Center for Multimessenger Studies in Europe. And so this is a project that has been funded by the EU. So the scope, which I hope that you can still see on the screen, is to create sort of a center that is actually virtual for the time being. Sorry, maybe I missed something. Can you still hear me and see the screen?
Yes, we can. Yeah.
Okay, sorry. Yeah, so the scope is actually this multi-messenger
Io comunque sto sclerando
studies.
perché sto correggendo.
Sarah, could you mute? Thank you.
Yeah, and multi-messenger is you know, not anymore the future, but the present. So with multi-messenger, you know, we have in mind the different wavelengths in electromagnetic spectrum, but also additional messengers such as neutrinos or cosmic rays, which are actually nuclei, and gravitational waves as well. And so we are trying to put everything together and to establish a link between the communities. This is really the underlying objective of the ACME project. So the reason why we want to add to the picture and to the game different additional messenger is that we want to have a sort of a full view on the sky over the different energy domains. And so if you take a look at this picture, you see here the distance. I don't know if you see my mouse, but you have the distance against the energy. And when you get to high energy with the electromagnetic spectrum, you start to be reduced in terms of distance on which you can probe the sky. And so essentially, photons, the universe starts to be opaque to photons and to also to cosmic nuclei. And therefore, you want to probe on the high energy scale and the and the distance universe with new messengers, and photons can, neutrinos can make it, gravitational wave can make it as well, because both are, you know, not deflected by the electromagnetic field, and also, you know, in particular, neutrinos interact very weakly with materials, and so therefore they can traverse large distances. So with this multi-messenger astronomy approach, it's really the insight on the source composition and their internal mechanisms that we are willing to target. And for this, we need a network of instruments. And so this project is an InfraServe project. So it is meant to develop the coordination and tools for harmonized access to the existing research infrastructures across the world. So we need for this is maybe a bit internal aspect, but I think it is fair to present that. We need to have a well-defined science case, because we are going to open calls to the community. And of course, the community is then, you know, called for responding to these projects, but we need to be clear what we can and what we cannot do. And so, because we were going to have to select those submitted calls for transnational access in particular, but also for virtual access to the infrastructures. And so what is at the core of our project in terms of phenomena is the matter in extreme conditions and the particle acceleration and propagation. We also would like to study gravitational lensing and explosive events, which relates to the time domain, and I will come back to this later. And we want to do this in the multi-messenger context that brings most of the information available to our community. So in terms of sources, we are essentially targeting compact objects at different scales, actually. And so these are you know, small, these are black holes mergers. These are active galactic nuclei, or binary neutron star mergers, or neutron star mergers with black holes, which essentially produce gravitational waves these days. But we want to take a look, of course, at the other components Pulsars are on our list as well, X-ray binaries and pulsar winds nebulae. Of course, this is a long list and with things in common and things different, and this is pretty rich. What is at the core in terms of source is also what I mentioned earlier, essentially whatever is astrophysical transients. And so here we're touching the gamma ray burst, the magnetars, the fast radio burst, and etc. So the list is pretty long. And actually on this graph, you see the luminosity against the characteristic time scale. So you see this is again very rich with a full a full landscape that we have to explore with the multi-messenger approach. However, there are things that we consider at first stage are not exactly on our portfolio of activities. For instance, the sun and the solar system object and exoplanets, for instance, or even the interstellar matter. But of course, there might be exceptions if we deem it necessary that it falls into the multi-messenger project domain. And same for the cosmological studies themselves, the early universe and the fluctuation in the cosmic microwave background. Even though this brings a lot of information, this is not exactly in the frame of the multi-messenger topics that we're touching. Again, we're of course very open to some of the exceptions. So the consortium of ACME comprises 42 partners across 15 countries, and we have more than 30 research infrastructures that participate to the project. This comes from radio to gamma rays, of course, but as I mentioned earlier, also gravitational wave interferometers, neutrino telescope, and cosmic ray detectors. So our project started in September last year and is meant to last for 4 years. We have received money from the EU, and initially our approach was supported by the Astroparticle Physics European Consortium and the Astronet Consortium as well, which is more on the astrophysics side, and the other one on the astroparticle side. And again, I think this is important to mention that this project is not only meant to do science, but also to bring different communities together and to pave the way for a future activities, actually. So the project structure is summarized here. So we have actually we need a need for coordination of the different activities, and then we have different work packages that are targeting different key questions. And so the harmonization between transnational virtual access to research infrastructures, the development of centers of expertise, and this is very new actually. I think this is one of the new things that we're bringing into this project. So we are developing centers so that the people can have access to them and get access to the expertise in each of the different messenger domain. Then, of course, we also want to improve science data project management because we are bringing different communities together. We'd like to have a better management of the real-time alerts, their observations, and also develop criteria for follow-ups. We would like to provide training for the new generation because we really think that this is the beginning, and then a lot will be for the future. And last but not least, we want to open data sets to other disciplines and increase citizen engagement. So these 7 points corresponds to 7 work packages. And of course, there are important links between the different links. So in terms of transnational access, we want to deliver access to multi-messenger and time domain infrastructures. They are listed here, for instance, and so we are working, for some of them, the programs are already available, and for some of them, more difficult, we are planning to open, to open this access, for instance, for the KM3net neutrino telescope that requires a bit of additional work because these communities are not very accustomed to this kind of things. So we're working into this direction with them. We want, as I mentioned, to open access to the experts. So we have different center of expertise, gravitational wave, neutrinos and cosmic rays, very high energy events, astronomy. We have radio astronomy, near infrared and optical astronomy, and X-ray center of expertise. And so the implementation and access to these centers will be based on hands-on sessions. There will be a sort of a help desk for user support that we are setting up, and there will be visits, physical visits to these centers of expertise, so that the people willing to have a specific analysis, cross analysis, will have access to these centers and data handlings. As I mentioned also, we want to improve access to archival multi-messenger data. It's not only the time domain, but we also want to have, access to the recorded data, so that you can look into the past for your specific search. And so here we have already a sort of constellation of tools that exist, and we are trying to put these tools not so much together, but at least to make sure that we can understand the different formats and harmonize the standards for having access to these different tools existing, and making consistent links between the different ones. Okay, and I mentioned as well that we want to improve the coordination of real-time detection. And so, here it's about, so you will hear about this today, later. But yeah, so it's about coordinating the alerts, coordinating with the users, and having access to the European brokers. And so our work package 5 is essentially dealing with this, and make sure that they will provide also some specific tools to manage and analyze the data streams. All right, as I mentioned, we have also a program for training of early career scientists and engineers. And so this is a picture of the first workshop that happened in Toulouse pretty recently. That was in April. This was the very first ACME workshop on gravitational wave sky and complementary observations. We have more than 100 participants, physically and remotely as well. And so this was really successful. And we will have more of this. They are scheduled we will have some, a handful of workshops of that kind per year on different domains. So this is really nice, because it started. And then we have, the citizen science program, and it is related to what you're going to discuss today. So of course I'm aware about the difference between lambda citizens and so let's not use the term amateurs, but people who are not paid to do astrophysics. So of course you are more keen with the domain, but sometimes we can also have access to a larger community in society, and this is really the citizen aspects that we are willing to develop as well. All right, so this is a short presentation, overview of what we're doing. I thank you very much for your attention. I encourage you to visit our website, which is pretty fresh, brand new, so you have information to the website. And if you're willing to, you can also follow us on LinkedIn. We have a page for that. I'm happy to answer any question, and thank you again for your attention.